So what exactly is the periodic table? The periodic table is an aid that we use in chemistry. It consists of pure elements. Now, an element is a pure substance that cannot be divided further into simpler substances. Elements are made up of pure atoms. Examples of atoms that exist are the sodium atom, chlorine atoms, oxygen atoms, and so forth. You find these in the periodic table. So for a very big number of atoms, we can have a pure element. And so that is why the periodic table is called the periodic table of the elements. That is because it contains a lot of elements that are made from pure atoms and cannot be divided further by chemical means or physical means. An example of a physical means is boiling or cutting. Say for example you have the element copper. Is it possible to split the copper into two and produce different substances? Say for example, if you cut the copper into two, will you have one part being copper and another being a different substance? Or will it still be copper? It turns out that it will still be copper, even if you cut it or if you heated it. And say by chemical means, we mean it cannot be broken down into simpler substances by processes such as electrolysis, the decomposition due to passing it through an electric current. So the periodic table is an organized arrangement of elements in order of their increasing atomic numbers, where atomic numbers means the number of protons. Starting from the very first element in the periodic table, hydrogen, the second being helium, the third being beryllium, so on and so forth. So as the number of protons increases, we add on the next element. So the basis on which the periodic table is made is increasing number of protons. Now protons are found in the nucleus of an atom. In the nucleus, there are protons and neutrons. Neutrons have no charge. Protons have a positive charge and electrons have a negative charge. As we'll see in the next slide, the periodic table is made up of groups and periods. When we get there, I'll explain what groups mean and what periods mean. However, it's not everything that we'll get to discuss in this video about the periodic table. So you'll probably learn most of the parts as we start talking about bonding. So if you haven't subscribed to this channel, make sure you do and click the bell icon to get notified every time I post a video to keep following. Now, here we go. This is a picture of the periodic table, and by groups and columns we meant this first row. I mean, it's not a row, it's a column. This first column, and the second column. This is another block of elements, and so if we count the columns in total, counting this off, we have 8 columns, and we call them groups. 3, 4, 5, 6, 7, 8. But if you want to count these as individual columns, you have 18 in total because there are 10 columns in between this block here. The block to the left is called the S block. This is the P block, D block, and the F block. The reasons for these will only be understood as we start considering the bonding of these substances with each other, as well as their electron configurations according to the quantum mechanical model of the atom. This key helps us name these groups according to chemistry. So the group 1 metals or the group 1 elements are called alkali metals, with the exception of oxygen, because oxygen is with the exception of hydrogen, where hydrogen is a non-metal, as you can see from here. This color is for non-metals, but it's placed in group 1 because its valence is 1. You can think of valence as the number of hydrogen atoms that is required to bond with a certain substance. Say for example, when we talk of carbon, we say the valence of carbon is 4. That means it takes 4 hydrogen atoms at most to bond with the carbon atom. The same could be said about fluorine. It takes only 1 hydrogen atom to bond with 1 atom of fluorine. So the valence of fluorine is 1. For all metals, 1, 2, that are not part of this transition block, these are called transition metal elements because they can have variable valences. Some of these have 1 and 2 valences, some of them have 2 and 4 valences. That's a topic for some other time. But for all these metals, the metals in group 1 have valency 1, metals in group 2 have valency 2. This column is made of metals, the ones in green, but the ones in blue are what we call metalloids because they exhibit properties of metals and non-metals. The group 7 elements are called the halogens. That's where chlorine, fluorine is, as well as bromine and the others. And this gray group is called the group of noble gases. These gases are hardly reactive at all. It's very hard for them to be found in any compound because they have the octet stability. They have a complete number of outer shell electrons, and so they do not want to react anymore. These are called lanthanides and actinides. The ones in yellow are lanthanides and the ones in green are actinides. They're in the F block because they fill up their F orbitals before they fill up their D orbitals completely. Like I said, we'll discuss this as we discuss bonding. I just wanted to give a brief overview of the periodic table as a special request from my email. So thank you very much for watching. Feel free to email me at captainthetutor@gmail.com. Subscribe to my YouTube channel and like the video. If you have friends, family who would like to watch such content, share the link and let them enjoy. Thank you for watching. Have a great day.